Dear students and my fellow viewers, I hope you all will be fine. By the blessings of Almighty Allah, I welcome you all. Here, I am with a new lecture. In this lecture, I will discuss with you the power of the lens. Dear students, let's define the power of a lens. The power of a lens is basically, dear students, a measure of the degree at which a lens can converge or diverge light rays falling on it. So, the power of a lens is basically a measure of the degree of convergence of light rays or divergence of light rays falling on it. You know that convex lens converges a light rays falling on it. Similarly, concave lens diverges a light rays falling on it. So the measure of the degree of this convergence and divergence, this is termed here as the power of the lens, or we can say the ability of a lens to converge or diverge the light rays falling on it. It is also given, dear students, power of a lens is also given, or we can say it is also defined as the reciprocal of the focal length of the lens. So power of a lens is also defined as the reciprocal of the focal length of the lens, that's f in meters. We can say power of lens p is equal to 1 divided by f in meters. So we can say numerically it is given. It has a numerical value p is equal to 1 divided by f in meters, where p is the power and f is the focal length of the lens in meters. Dear students, a lens of short focal length has more power as compared to a lens with long focal length, because power and focal length, they are, we can say, they are inversely proportional to each other. If the power of lens is more, that means focal length is less. If the focal length of the lens is more, that means power is less. That's why I said here a lens of short focal length has more power as compared to a lens with long focal length. Got it here? Dear students, the SI unit of the power of the lens is dioptry, which is represented by capital D. You need to remember this point, that the SI unit of the power of the lens is dioptry, represented by D. Sometimes you may be asked in an examination, define dioptry or define one dioptry. Okay, so when this type of question will be asked in the examination, you will define it that one dioptry is the power of a lens whose focal length is 1 meter. So this is very simple definition here. So 1 dioptry or 1D or simply D is the power of the lens whose focal length is 1 meter. Here it's okay, dioptry. Now I am here with some numerical that will help you to understand the power of the lens. Dear students, here is the numerical. Calculate the power of a convex lens of focal length 25 centimeter. We have got a convex lens whose focal length is 25 centimeter. We need to calculate its focal length. Dear students, here focal length f is equal to 25 centimeter. So this 25 centimeter can be changed into meters. So we need to divide this 25 by 100. That means 25 by 100, that's called 0.25 meter. So 25 centimeters is equal to 0.25 meter. Thus we can calculate the power. Power is equal to 1 divided by f in meters. Here p is equal to 1 divided by 0.25 m or meter. That's equal to 4d. अगर हम 1 divided by 0.25 करेंगे तो हमें क्या मिलेगा? We will get the 4. Here d is the unit, so 1 divided by 0.25 is equal to 4 dioptry, or it is we can say plus 4d. Okay, the power of a lens is 2.5 dioptry. You got this here, this numerical. Now the second numerical, dear students, the power of a lens is 2.5 dioptry. What is the focal length and the type of the lens? Now in this case, power is given, you have to find the focal length of the lens. Here, power of a lens p is equal to 1 divided by f in meters. Since p is equal to 2.5d, thus we can write here 2.5 is equal to 1 divided by f. So that's equal to, यहाँ पे f क्रॉस मल्टीप्लिकेशन 2.5 इंटू f इज इक्वल टू 1, क्योंकि इस साइड में कुछ नहीं है. सो दस f इज इक्वल टू 1 डिवाइड बाई 2.5, दैट्स इक्वल टू 0.4 मीटर. 0.4 meter. So this 0.4 meter can be converted into centimeter by multiplying it with we can say 100. So here we will get 0.4 meter is equal to 40 centimeter. The focal length of the lens, dear students, is equal to 40 centimeter in this case. Since the focal length is positive, therefore lens is convex. You need to remember here this point, that focal length of convex lens is positive, while as the focal length of concave lens is negative. Similarly, the power of the convex lens is positive, while as the power of the concave lens is negative. Here I am with one more numerical. This will help you to understand this power nicely. Find the power of a concave lens of focal length 2 meter. Here you have got a concave lens whose focal length is 2 meter. So we will write the solution. Focal length of the lens, that's equal to minus 2 meter, because concave lens. Here I have mentioned it, this is concave lens, so the focal length of this lens is equal to minus 2 meter. Now therefore power P is equal to 1 divided by F, that's equal to 1 divided by minus 2, that's equal to minus 0.5 D. Here we get the power of the lens is equal to 0.5 D, but minus. This minus sign indicates that this lens is concave. If this would have been convex lens, here would have been a positive sign. Got it here? One more numerical for your understanding. Dear students, what is the power of a concave lens of focal length 50 centimeter? So you have got a concave lens whose focal length is 50 centimeter. So you need to find the power of that very lens. So here we will write in the solution that focal length of lens f is equal to 50 centimeter. So we need to change this centimeter into meters. So 50 divided by 100, that's equal to 0.5 meter. 0.5 meter. Since this lens is concave, thus focal length f is equal to minus 0.5 meter. So we can calculate here the power. Dear students, power P is equal to 1 divided by F in meters. That's equal to 1 divided by minus 0.5. That's equal to minus 2 dioptry. Here you got these numericals and you got the whole lecture regarding the power of the lens. Dear students, I hope that you have got this lecture nicely. Inshallah, I will meet you in a next lecture. Till then, Allah Hafiz.